Welcome to the QFR explanation movie. Here we show you how to perform a QFR analysis. We begin with loading in the patient images by double-clicking on the patient row. And as you can see here, the images are loaded into the viewer. Now we have to start up the application, the QAngio XA 3D application that has the QFR feature. We're going to the top left of our screen, and by clicking the button you can see that the application is launched. We drag in the images into the application and we arrive at the first step. In this step we have to find the end-diastolic phase in both series. And as well a good contrast filling of our target vessel. We can do this by using the scroll wheel, walking through the frames and finding the end-diastolic phase frame. And as well a good contrast filling. And as you can see here, walking through the frames, that frame 29 is the correct frame. We do the same thing on the right side, using the scroll wheel for finding the correct frame. And as you can see here, frame 29, 30 is the correct frame. So now both images are synchronized in the same point of the cardiac cycle. We can continue to the next step by clicking the single vessel analysis button in the top of our screen. In this step, we have to indicate an anatomical landmark. So we have to pick an identical location in each selected frame. And in this example, it is advisable to select this anatomical landmark close to the diagonal and septal branch that we can identify as well in the right image and can place correctly the offset correction at the same location. Based on these 2 points, the system now knows how both images are related and can reconstruct a 3D model in the next steps. When satisfied with this procedure, we can continue to the next page by clicking the next button in the lower right of our screen. In this step, we have to select the segment we like to analyze in our target vessel. We begin by placing the proximal point in the left image onto the ostium of the LED, and as well placing the distal point distally in the LED. And as you can see here, by placing the points, the system automatically places the points as well on the right side and performs a contour detection. As you can see here, a little adaptation is needed. I have to relocate the proximal point on the right image to the identical location of the proximal point in the left image, like here. For a better view, we can press zoom image to contours on the right side. And we can see here that we have to apply as well some contour corrections on the proximal ends. We can do that by picking up the yellow contour line and placing a correction point with the left mouse button. As well, we can do this on the right side, applying a little correction on the proximal end of our selected segment. And we have a nice performed contour detection. When satisfied with this step, you can continue to the next page by clicking the next button in the lower part of our screen. And here you can see, based on the selected frames and as well the contour detection, we have now a 3D model of our target vessel. And based on this 3D model, we also provide you now with a vessel diameter function graph on the right side, where you can see that the system already automatically detected the lesion, as indicated with the green vertical lesion markers in the graph. As well, based on these anatomical information, we can provide you some anatomical characteristics of the vessel on the right side in the column. In this step, we have to answer 2 more questions. The first one is about nitroglycerin. You always need to administer nitroglycerin, otherwise we cannot perform an accurate calculation of QFR. And the last question we have to answer is what kind of vessel are we analyzing? Because this algorithm takes into account the differences in hemodynamics between the vessels to calculate the value. And in this example, it's obviously an LAD. And by clicking the segment, we get immediately the fixed flow QFR. This fixed flow QFR value is the so-called quick calculation. Well, the algorithm calculates with a fixed flow velocity of the blood through the coronary and this parameter is empirically proven with scientific medical research. But, of course, there is a chance that this patient has a lower or higher blood velocity compared to the population average. And to counteract for this difference, we can perform a frame counting. And with this frame counting, we can find out the true blood flow through the target vessel. So we can make this QFR calculation patient-specific. When activating the frame counting option, we can select either to work with the left or the right selected series, and by default it always works with right. To conduct a frame counting, we can use the scroll wheel and use the lower right screen to find the frame where the contrast passes the begin part of our segment. As well, we can find the frame when it passes the end part of our segment. And the differences in frames we use to calculate the blood velocity, because we as well quantified the vessel length during the quantification of the 3D model. And as a result, these two concepts we can use to calculate the average blood velocity. So, in this example, I use a scroll wheel to walk through the frames, finding the frame where the contrast passes the first point of our selected segment, and you will see that frame 4 is the frame where the contrast passes the begin point. So we annotate this frame on the right side with start frame, and going to look for the frame where it passes the distal point. And as you can see here, we're just too far, so we have to scroll back a little bit, and then you will see that frame 12 is the correct frame. So I annotate this frame on the right side as our end frame, and then we have to answer one more question. Depending on the version you have installed of QFR, you have the question about the patient state, either if it was in contrast, no stress state, or in hyperemic stress state. If you have the standard edition of QFR, it's always by default contrast. Do you have the advanced edition, you get provided with this additional option. In this case, only contrast was applied. When satisfied with the frame count, you can continue to the next page. We're going to the next button, and as you can see here, we are arriving at our final page with all the QFR values. As you can see here, the color-coded scheme is now indicating the pressure drop over our 3D model, and as well, we provide you now with a pressure drop graph in the lower right part of your screen. And on the right side, in the column, you can see the 4 QFR values. Here you see the vessel QFR value of 0.84. This is the QFR value calculated over the complete selected segment. So it is the pressure drop measured from the begin point to the end point of our segment. The second value is the lesion QFR, as well 0.84. This QFR value is calculated between the green vertical lesion markers that demarcate the lesion. So at this current position of these lesion markers in this example, the relative pressure drop is 16%. The third value is the residual vessel QFR, here 1.00. This is a prediction value. It predicts how the vessel QFR will jump up if the selected lesion is recovered, treated. So in this situation, the vessel QFR will jump up from 0.84 to 1.00. The last value is the index QFR, here 0.84. This value is calculated from the begin part of our selected segment until the position of the white eye line. And this white eye line, you can see it in the angio, in the graph, as well in our 3D model. And by picking up and sliding this white eye line over our graph, you can find on any position on the vessel the QFR value. And as you can see on the right side in the column, depending on where the line is placed, we get instantly the updated value of the QFR. As well, we provide you with anatomical information, like the lesion length, here 45 millimeters long, and as well the diameter stenosis and area stenosis, and as well the proximal and distal diameters. When you finished your QFR calculation, you have to close it down by pressing the Done button in the lower right corner. And please do not forget to save your QFR calculation by going to the top right corner and press the Save button. This was the general overview on how to perform a QFR analysis. If you're interested in a more detailed explanation on any part of our QFR calculation steps, please consult the other QFR movies.